Okay guys, so this is your boot camp on ozone. Look, cover, right, check, repeat, repeat, repeat. So what we've got here is the formation of ozone, two equations. It is worth noticing in this first equation that the O2 does absorb UV light, but this is not how ozone protects us against UV. So the type of UV radiation absorbed in this formation step is not the type which would harm us really that much anyway. So don't think that this is how it protects us. It just so happens that O2 absorbs the UV to break, and that'll be via homolytic fission. But as it's a double bond break-in, we don't actually end up with a radical, because we don't end up with an unpaired electron. If you draw the dot and cross diagram, you'll see that. We've then got the action, which is two steps, and in the UV there, that's the UV which we want absorbed, so that's how it's protecting us. And then finally the removal. So 5 minutes guys, look, cover, right, check, repeat, off we go. Just a few more minutes. These equations work really well with the bootcamp method because it really is just memory. There's not too much understanding here, it's just memorizing them. One more minute left guys. Okie dokie guys. So this next slide is about destroying the ozone. Obviously ozone is destroyed naturally as we saw in the last slide, but chlorofluorocarbons speed up this process. Just a little point, I've put a chlorofluorocarbon as CFCl3. The ratio of fluorines and chlorines doesn't have to be that. For example, it could be CF2Cl2 or CF3Cl, but CFCl3 is the most common one, that's why the one I've gone for. In most mark schemes as well, it actually says you don't need to include the dots for the radicals, but really we should do because they are radicals. So we've got the initiation, to propagation, and then the overall reaction. You can get the overall reaction by cancelling out the radicals in your propagation step. So 5 minutes from now, guys, off we go. Halfway there, just 2.5 minutes left. Ever since international cooperation operations like the Montreal Protocol, CFCs have been not really used in the Western world. So they used to be used in aerosols and in fridges and refrigerants, and not anymore. So that's one of the ways we're helping to protect the ozone using international cooperation and legislature. Okie dokie, guys. So finally, this is another way of destroying the ozone. This is with nitrogen oxide radicals, which are produced by the fusion of N2 and O2. Well, an N and an O from an N2 and an O2. This happens in car engines. Remember, we did this equation with catalytic converters, but also a lot in aeroplane engines. Obviously, it gets very hot in there. Now, where do aeroplanes fly? At the top of the troposphere, bottom of the stratosphere. Whereas the ozone layer, right in the stratosphere. So aeroplanes are like the perfect assassins. The gases they release are right where they can do the most damage. You'll notice as well the propagation 1 and 2 for your NO radical is basically the same as for your Cl radical from a chlorofluorocarbon. So the overall equation is identical. So there's a lot of similarities between this slide and the last one. That's worth remembering. That'll help you remember it a lot better. So 5 minutes from now, guys, last slide this is, off we go. Okay guys, try and get down a couple more times. Really do try and remember those similarities between this and the last one. That'll definitely help. Okay guys, so that's the ozone boot camp. Well done for doing that. I'll see you next time.